Greetings of the day. I am Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process. Today's topic is laser beam machining. Right. At the end of this session, student will be able to understand the various parts in laser beam machining. This is the course learning outcome of the today's topic. Right. Under non-traditional machining process, we have three broad categories, namely mechanical, thermal, chemical and electrochemical. In mechanical, we have ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. In chemical and electrochemical, chemical milling, plasma chemical milling, electrochemical milling. In thermal, we have electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. Today we are discussing laser beam machining. Okay, right. Introduction of laser beam machining. Modern machining methods are established to fabricate difficult to machine materials such as high strength thermal resistant alloys and various kinds of carbides, fiber reinforced composite materials, stellites, ceramics. These are the very high strength thermal resistance and hard materials. For this, laser beam machining is best suited. Conventional machining of such materials produces high cutting force. In some particular cases, may not be sustained by the workpiece. Okay, so when the material is hard, we have to go with high cutting forces. So because of this high cutting forces, the workpiece may disturb. That means the workpiece may not be sustained. Okay, so at those conditions, we have to go with sensitive machining methods. So one of the sensitive non-traditional method is that laser beam machining. So laser beam machining offers a good solution that is indeed more associated with material properties such as thermal conductivity, specific heat, melting and boiling temperatures. Okay, so laser beam machining is best suited for the hard materials which are having the properties thermal conductivity, specific heat, melting and boiling temperatures. Okay, right. Power densities. So before we discuss about power densities and all these, so far we have discussing that LBM is laser beam machining. So L stands for laser. What is laser? The full form or the abbreviation of laser is that light amplification by stimulated emission of radiation. Let me reiterate. Light amplification by stimulated emission of radiation. So the first letters of all these combinedly laser, LASER, laser. Okay, so the short form of light amplification by stimulated emission of radiation is laser. Okay, so in usual manner, most of the common people are using when they go to hospitals and some other laboratories, some laser print and laser technique, laser methodology. Even they don't know the background of this light amplification by stimulated emission of radiation. They use it to say laser, laser, laser. Okay, so the background of the laser is that laser, full form, light amplification by stimulated emission of radiation. Okay, right. A highly collimated, monochromatic, and coherent light beam. Okay, so laser is a highly collimated, monochromatic, and coherent light beam is generated and focused to a small spot. Okay, and its power density is 106 watts per square meters. Okay, this is the high power density of the laser beam. Okay, right. Next, variety of lasers. Okay, a large variety of lasers are available in the market, including solid state, semiconductor, molecular, ion, neutral gas. Okay, right. Molecular types in either continuous wave, that is CW, or pulsed mode, PM. Okay, now let us see CW and PM, means continuous wave and pulsed mode. Okay, right. Molecular types in either continuous wave CW or pulsed mode PM of operation are detailed in this table for different laser types. Okay, so here in solid we have three kinds: ruby, okay, ND-YIG, ND glass. Okay, and the wavelengths in nanometers are given 694, 1064, 1064 for these three materials. Okay, and its performance, this is pulse 5 watts. Okay, so for ruby it is exclusively pulsed and its performance is 5 watts. Okay, right. And for ND-YAG in solid laser type, it is given pulse CW, that means continuous wave. Okay, that is in the range 1 to 800 watts. Okay, right. For ND glass, this is also pulse continuous wave 2 milliwatts. Okay, again for semiconductor GAAS material, the wavelength is 800 to 900 nanometers. It is pulse continuous wave. Okay, that is 2 to 10 milliwatts. Okay, for molecular, that is for carbon dioxide CO2, that is 10.6 microns. Okay, so it is not nanometers, that is mu m microns. Okay, so pulse and continuous wave. Okay, so that is less than 15 kilowatts. For ion, AR plus or SNP plus, that is 330 to 530 nanometers. It is also pulsed type and continuous wave. Okay, that is 1 watt to 5 kilowatt. Right. Excimer 200 to 500 wavelength in nanometers, and it is pulsed type only. Okay, pulsed mode. Right. For natural gas, helium neon, the wavelength is 633. This is only exclusively continuous wave and 2 milliwatts. Okay, so here it is exclusively continuous wave and the ruby is exclusively pulsed, and in between these two are combined with pulsed mode and continuous wave. Okay, right. Right. Applications. Lasers are widely used in many industrial applications, including plating, heat treatment, cladding, alloying, welding, and machining of different materials. Okay, so let me reiterate the various applications of lasers: plating, heat treatment, cladding, alloying, welding, machining. So all these are industrial oriented applications. So along with these industrial oriented applications, we have applications in medical and the other sectors. Okay, right. Right. Let us see the schematic of laser beam machining. Okay, so the figure 1 depicts laser beam machining setup. Okay, so here total reflecting mirror, this is laser material. Okay, flashlight, elliptical reflecting cavity, partial mirror, lens, and here we have CNC control. This is position table, this is focal length, workpiece. Okay, so here this is a spot from the laser. Okay, so like electron beam machining, here the laser beam machining also pointing on the workpiece at one spot. Right. Insights of laser beam machining. In short, LBM, laser beam machining. Laser beam machining is a cutting edge and highly precise manufacturing process. Okay, it is a highly precise manufacturing process that harness the remarkable properties of laser beams to shape and transform materials with exceptional accuracy. So here laser beam machining is a highly precise manufacturing process and at the same time high accuracy in shape and size of the materials is possible. Okay, right. Excuse me. Next, advantages of laser beam machining. Utilizing the focused intensity of coherent light, LBM offers numerous advantages. Okay, in including non-contact machining. Okay, so here no question of contacting the workpiece material, so that no cutting forces involved in it. Okay, this is the major advantage of the laser beam machining. Okay, it is a non-contact machining, minimal material waste. Why? Because it points on spot. That means here a surgical material removal is taking place, and at the same time there will not be any maximum heat zone. Okay, right. The ability to work with a wide range of materials from metals to ceramics and polymers. Okay, so here the ability to work with a wide range of materials from metals and ceramics to polymers. Okay, metals, ceramics and polymers. Okay, so this is the greatest advantage of laser beam machining. Right, broad applications. Okay, this innovative technique has found application in various industries and other fields such as aerospace, electronics and medical devices. That's what I told you. The laboratories, medical laboratories, we use laser beam usually. Okay, right. Where intricate components demand unparalleled precision and intricacy. Okay, so with laser beam machining, we can cut intricate shapes on workpiece. Okay, so through conventional machining process, it is very difficult to cut this kind of complex profiles. But with laser beam machining, if we have any kind of path, the laser tool can travel over that path and that it can cut the material line by line or point by point. Okay, right, right. Laser beam machining is a precise non-contact machining process. That's what we have discussed. Okay, there will not be direct contact to the workpiece with forces. Okay, right. That utilizes a focuser laser beam to remove material from a workpiece. Okay, widely used in industries such as aerospace and electronics. That's what we have discussed, and even medical device manufacturing. Okay, right. Even medical laboratories. LBM offers high accuracy and minimal heat affected zones. Okay, so here the most advantage feature is that high accuracy and minimal heat affected zones. Why? Because here laser beam remove the material from the workpiece in a surgical way. Okay, wherever we want to remove the material, there only the spot or the laser beam spot will pointing, and with different material removal processing mechanisms that it will be removed, that we will discuss in detail in the coming presentation. Okay, right. It's ideal for intricate designs and delicate materials with high versatility. Okay, so laser beam machine offers manufacturing for intricate designs and delicate materials. Okay, right. Laser beam machining is a is an innovative, non-traditional method of material removal accomplished by employing focused laser light. Okay, the cutting edge technology or this cutting edge technique harnesses the intense heat generated by laser beam to melt and vaporize the workpiece material at high speeds, effectively removing material from the surface. So here the mechanism of material removal by laser beam machining is melting and vaporizing. Okay, so this laser beam machining technique harnesses the intense heat generated by the laser beam to melt and vaporize the workpiece material at high speeds, effectively removing material from the surface. Okay, right. Widely utilized in the machining of both mel- metal and non-metallic materials. Okay, so here laser beam machining is suited for or machining for metals and non-metals. Okay, right. Laser beam machining involves creating high energy laser beams that strike the workpiece, transferring their thermal energy to the surface. So here high intensity of laser beam when reaches the workpiece, the thermal energy will be creating and subsequently it melts and vaporizes the workpiece material. Okay, right. So here high energy laser beam that strike the workpiece, transferring their thermal energy to the surface. So because of this high thermal energy, the workpiece will melt and vaporize. So subsequently the material removal will take place. Okay. Oh, so however, we'll discuss in detail the material removal mechanism. Okay, right. This process known as light amplification by stimulated emission of radiation. Okay, that is laser. Light amplification by stimulated emission of radiation, that is laser, enables precise and intricate material shaping, making it an indispensable technology in various industries. Okay, so here intricate shapes and even the material is very delicate also, the machining can be easily done. Okay, so even it is hard or delicate, here because of the laser striking on the workpiece, it just melts and vaporizes the surgical part, so that will not create unwanted heat affected zones and any other thermal effects. Okay, right. Right. Now let us discuss the various parts of laser beam machining. First of all, let us see the power supply. The power supply is responsible for providing electric current to the system. Okay, so that it has not given in this schematic, but however, laser beam machining needs input of some power supply. Okay, right. A laser beam machining, a high voltage power system initiate the reaction in the laser. Okay, so here high voltage power system is required, which in turn machines the material. Okay, the high voltage supply facilitates easy initiation of laser pulses. Okay, so here high voltage power system finally facilitates easy initiation of laser pulses. Okay, right. Capacitor. A capacitor bank charges and releases energy during the flashing process, forming a significant part of the machining cycle. Okay, so capacitor is to charges and releases the energy during the flashing process. Okay, right. It operates in pulsed mode, facilitating efficient charging and discharge. Okay, so here the capacitor enhances its capacity whenever it needs, and it stores the energy. Okay, whenever it is not required, it will store constantly. Okay, right. Next, lamps. Flash lamps. Electric arc lamps, known as flash lamps, produce intense white light that is converted into coherent high intensity beam. Okay, so here flash lamps are known as electric arc lamps. Okay, produce intense white light that is converted into a coherent high intensity beam. Here high intensity beam is because of flash lamps. Okay, these lamps are filled with gases that ionize to generate substantial energy, causing melting and vaporizing the material on the workpiece. Okay, so here high intensity beam because of flash lamps, okay, which are filled with gases that leads to ionize the substantial energy, causes melting and vaporizing the material on the workpiece. Okay, right. Reflection mirror. See here we can see the reflection mirror here. Okay, reflecting mirrors come in two main types: internal and external mirrors. Okay, so reflecting mirrors are of two types: internal and external. Internal mirrors, also called resonators, are crucial for generating, maintaining and amplifying the laser beam. Okay, generating, maintaining and amplifying the laser beam. Okay, they direct the laser beam towards the workpiece for material processing. Okay, they direct the laser beam towards the workpiece for material processing. Okay, so internal mirrors, also called resonators, are crucial for generating, maintaining and amplifying the laser beam, and they direct the beam towards the workpiece for material processing. Okay, so these are the two things to be carrying out by these resonators, nothing but internal mirrors. Okay, comes under reflecting mirror. Right. Laser light beam. Okay, laser light beam. The laser light beam is the focused radiation produced through the process of optical amplification based on the coherence of light generated by bombarding active material. Okay, so here laser light beam is focused radiation produced through the process of optical amplification based on the coherence of light generated by bombarding active material. Okay, right. Ruby crystal. So here uh, this can be ruby here. We can use other materials also. Okay, in certain types of lasers like the ruby laser, coherent pulses of a deep red light are produced through a concept called propulsion inversion. Okay, sorry, population inversion. Okay, in certain types of lasers like the UV laser, coherent pulses of deep red light, okay, deep red light are produced through a concept called population inversion. Okay, usually most of the lasers are set up with ruby lasers. Okay, right. Ruby is um, comes under the category of some stone. Usually we call ruby stone. Okay, okay, right. Ruby lasers belong to the category of 3-level solid state lasers. Okay, right. Lens. Okay, lenses are employed to concentrate the laser beam onto the workpiece accurately. Okay, see here, lenses. Lenses are employed to concentrate the laser beam onto the workpiece accurately. So here the surgical or spotting on the workpiece is very much required for the exact material removal. So for this, lenses are employed to concentrate the laser beam onto the workpiece accurately. Okay, right. The laser light first enters an expanding lens and then collimating lens. Okay, so here we have two lenses. One is laser light and the collimating lens. Okay, which aligns the light rays in parallel, and the expanding lens adjusts the laser beam to the desired size. Okay, the laser light first enters an expanding lens, the first one, and then a collimating lens, which aligns the light rays in parallel, and the expanding lens adjusts the laser beam to the desired size. Okay, right. Workpiece. The workpiece, which can be made of either metallic or non-metallic materials, undergoes the laser machining process. Okay, the versatile machining method is suitable for working with a wide range of materials. So here, metals, non-metals can be machined by using laser beam machining. So these are the reference associated to this laser beam machining. With this, I conclude. We'll see the material removal mechanism in the subsequent presentations. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.